This is a companion video to BlackThornProd's Past the Game challenge that I took part in a while ago. I'm gonna go over in more technical detail how the things I added actually function, so we're gonna be looking at some code. My game dev content generally is aimed at people who are interested in seeing how stuff works, so hopefully you're into that. Let's go! Creating something to hold difficulty settings is actually quite easy. Implementing it into an existing game architecture, not so much, as you're essentially creating spaghetti code each line you write. In a non-game jam game, I would have done this more carefully. Difficulty is its own class, which I can add any values I want, and then simply have any class like a spawner for enemies and ammo read these values instead of something hard-coded. Then, incrementing current difficulty, all the systems that read values from a list of difficulties will change dynamically. In a more thought-out system, this could function with an observer pattern, and each class could decide on its own what it wants to do with the current difficulty level, but this kind of a system is good enough for a game jam game, which Past the Game challenges essentially are. This game was built to run in a single game scene, and removing almost anything caused something else to break. This is what's called spaghetti code, as if you yank one piece, something else comes along with it because they're stuck together. Making simplified scenes for the tutorial was like performing surgery until I finally had a fairly clean copy of the game scene. I need to be able to switch scenes when the player completed the tutorial-specific tasks. There's no pooling in this game, so an item is always destroyed. So I simply made this class which loads the next level with some delay when a supplied game object is destroyed. In tutorial level 1, it's the power cell, and in levels 2 and 3, it's the single enemy in the scene. Also, in the second tutorial, the ammo will always respawn if the player has 0 ammo. I just made a completely separate ammo spawner class for this one scene. Same basic principle in tutorial 3, as if the player uses any power-up, the power cells will instantly respawn. This was again a custom class that's only used in this one scene. The obstacle spawner is pretty basic, except that I wanted everything to always match the grid. How the code works is, we get a random direction from the center of the level, get a point a random distance away in that direction, floor the x and z coordinates, and if they're even, we add 1 to make them odd. This is because I know the grid square center positions are on odd integers in Unity's coordinate system. Last, we add some randomness to the height value to make z-viding less likely to happen. It still does happen, but, well, less likely. After we have a point, we check with a physics query if there's already an obstacle within some range of where we're going to spawn. If so, we try again up to 25 times before we just let the overlap happen. This is to prevent an infinite loop in case somebody were to crank the amount of obstacles so high that they wouldn't fit. It's hacky, but I didn't know I would be the last dev, so I tried to make it foolproof. In BlackThornProd's video, I didn't mention these data trails I added, but they function on a similar logic to the obstacle spawner. It's an empty game object with a trail renderer that's only allowed to turn on even coordinate integers, because the even numbers are the grid lines. There's a built-in callback function in Unity called onBecameInvisible, which is called when a renderer of any type is not being seen by any camera. If the trail goes outside the camera's view, it's teleported back to one of the several hand-placed starting positions and begins moving again. For testing purposes, I noticed that Unity's editor scene camera also counts, so this callback won't be called if the editor's camera can still see the renderer. Just a heads up if you wonder why it's not working for you. A major problem that's still visible in the game that it's difficult to stop a trail renderer from drawing itself, and snapping an object to a position draws one really big, long, thin trail. You can still see this in the final game as I didn't have time to fix it. This was surprisingly difficult. I didn't make the bullet system, so I needed to find a way to add something into it that it didn't quite fully support. Having a bullet damage an enemy and keep moving was almost impossible without changing how all bullets work, so I cheated. The bullet base class has a built-in spawn-on-death object which is made for particle systems, but so I made a simpler kind of bullet that spawns when you hit something and then it turns to face the closest enemy it can find within some radius. I tried doing this the proper way for longer than I care to admit, until I just decided to cheat. Another fun exercise to add something onto an existing architecture. All enemies have an A-star pathfinding component and procedural animations. The enemy is basically just its head, which follows the player. The head keeps a list of positions it's been to and adds a new one after it's certain distance from the previous one. Then it moves all its body pieces towards the next point. The body pieces don't have any logic on them except for their procedurally animated legs. Then there's a line renderer that connects all the pieces. This was the most difficult thing to get working. I was stressed and tired, and this was one of the last things I did on the challenge. It took me forever to get all these -1s correct, so it wouldn't glitch out. This probably would have been much easier if I hadn't made the enemy completely dynamic. Everything is adjustable. You can just change the body's length from 1 to 100 and everything works. If I had set a number of body parts, I could have simply built the worm by hand. I did it this way in case someone wanted to make the worm grow or shrink or be able to cut in half, but again, I didn't know that I would be the last dev, so The scene transitions and text streams in between is actually a useful technique if you didn't know this. You can tell a coroutine to stop its execution until another coroutine has finished. Essentially, you can nest coroutines inside a master coroutine. This is great if you want to code a dynamic sequence of events where you can adjust the speed or duration of each element individually. Like here, the show info text coroutine will type a sentence, let it display on screen fully legible for 3 seconds, and then erase it. And after that, the transition in the parent coroutine will run. You probably know about wait for seconds, but there are other yield types in Unity, like the wait while, which will yield the execution until the delegate inside the wait while evaluates true. Like in this instance, it will wait until the transition object, in this case just a black screen moving in front, calls the transition complete callback. It doesn't care how long or what kind of transition it is. It doesn't even know. It will sit still like a good little dog until it's told to do the next thing. You could, for example, have a coroutine wait until a player presses a button, or a sound file has finished playing, or an enemy is killed, or whatever basically. Again, the system is unnecessarily modular. I made it so someone could add scene transitions or make them more polished and fancy without worrying about the underlying logic of switching scenes mid-animation. Lessons learned. For me, this was the first time working on somebody else's code. I wasn't sure I could read somebody else's work and figure out how it functions, so I was a bit worried, but it turns out I could. Also, this gave me confidence that I know the Unity engine so well that I can, for most simple things, just decide what I want to do and figure out how to do it while I'm at it. If you learned something new from this video, please let me know. It's game dev videos like this that taught me how to code, so I'd be happy to share any knowledge you find useful. Until next time.